So the first one, TLO4, and then 2 minus charge. I told you guys that TL had a charge of -2, so that means it's in the same group as oxygen, sulfur, whatnot, and then oxygen is really oxygen, so obviously TL can't be an oxygen spot. That means it's going to be less electronegative, so we're going to stick it in the middle, and it should have 6 valence electrons, and then oxygen has 6 as well. So I'm just going to go ahead and place those oxygen around with the valence electrons, and then I'll be right back. Alright, so now that I have all my oxygens, first thing I'm going to do is connect everything to the central atom. Some of these connect easily, but then I'm going to have to split the lone pair to connect my other oxygens. When I do that, it kicks out the electron goes and joins somewhere that needs joining. So this one's going to connect out and join here. It does have a -2 charge, which means that there's 2 extra electrons in here. And where are they? Well, one can join right here and one can join right here. That gives everybody a full octet, and that makes, oh, that was TL, not TI. That makes TL basically look like this, which is actually the same configuration as the sulfate ion. So there were a few things that it asked. First, it asked you electron pair geometry. So for a shape like that with 4 things coming off of it, that is tetrahedral. Then it asked for the shape. The shape is also tetrahedral. The only time the shape is different from the electron pair geometry is if one of those things on the central atom is a lone pair instead of a bond. So tetrahedral has 109.5 degrees bond angle, ABCD, sorry, D. The hybridization with 4 things coming off the central atom, that's 1s and 3 p orbitals all hybridized to make 4 hybridized orbitals. Polarity, I know that the oxygens are more polar than that TL in the middle. So when I draw those arrows on the bonds showing the direction that the electrons are going to be pulled the hardest, I can see that they're all being pulled apart, which means that I don't get a dipole moment. So because I don't get a dipole moment, it's a nonpolar molecule. When your electronegativities compete, you're going to get a nonpolar molecule. When they add together, you're going to get a polar molecule. The last one, it asked for resonance. Because I don't have any double bonds there is no resonance. The other atom molecule that was asked for was SaO3 with a 2 negative charge. And then your clue for O was still oxygen, but your clue for Sa said that it was in the same group as carbon. So that means it has 4 valence electrons. So I'm going to go ahead and draw my oxygens, and I'll be right back. All right, now that my oxygens are drawn, I'm going to connect them all to the central atom, which leaves me with 4 electrons that still need to be bonded. I still have 1 in the center here that needs to be bonded, 1 and then 1 on each of my oxygen that still needs to be bonded. So I'm going to go ahead and create a double bond here. And then I can't do the bond here, right? I can't make like a triangle like that. That's not stable enough because there's too many electrons in there. They push too far apart. But what I can notice is this was an ion with a -2 charge. That means that there's 2 electrons added in there. So I'm going to add them where they need to go in order to give 8 electrons to each atom. So I'm going to redraw this all nice and pretty, and that was a -2 charge, and go ahead and answer the questions for these ones. So with 3 things coming off of my central atom, I have a trigonal planar shape, or I'm sorry, electron pair geometry. The shape is actually the same because nothing on my central atom is a lone pair. They're all bonds, so those match. The bond angle for trigonal planar is 120 degrees. The hybridization for 1, 2, and then 3 things is sp squared, so 1 s orbital and 2 p orbitals. hybridized to make an sp2 hybridized orbital. Polarity. So I know that oxygen is more electronegative than anything in the carbon group, which means that those electrons are pulling away from each other, since again they're all competing just like they were on the last one. This is a nonpolar molecule. And then resonance. Yes, there's resonance. This double bond, it could have gone where it is, but it also could have gone here, it could have gone here. So it actually has 3 different resonance structures.